So it seems when I did the video for our review worksheet, assignment number 24, trig graphing and inverses review, this one, I neglected to do the problems on the back. So, number 31, we've got some vertical asymptotes. We've got one up and one down. We've got 3/8 3, and we have 9/8 negative, oh, no, not -3, but 1. And we know that this is x equals 3/2, and here we have x equals 0. Okay, so let's start with our period. Period equals ending x minus starting x. So here's our ending x, here's our starting x. We have 3/2 minus 0, or 3/2. Now we know that our b value is 2 pi, because we're doing sine, cosine, secant, or cosecant, over period. Remember, if we were doing tangent or cotangent going backwards, this wouldn't be 2 pi, this would be pi, because the normal period for tangent or cotangent is pi. So here we're going to have 2 pi over 3/2, which is 2 pi times 2 over 3, or 4 pi over 3 for our b value. Our c value is our starting x, and that is 0. What else do we need? We need a d value. We know d is the average of the high and low y's. So 3 and 1. 3 plus 1 divided by 2. Remember, we're averaging two numbers, so we add those two numbers together and divide by 2. We get 4 over 2, or 2. And then finally, what about our amplitude? Well, we said amplitude was high y minus d, and in this case that would be 3 minus 2, or 1. So I write y equals 1 secant our b value, 4 pi over 3, x minus our c value, 0, close two parentheses, plus d. Now, how did I know it was secant? Well, I know it's secant because it's got one up and one down. I know it's positive secant because I have up and then down and not down and then up. But if you're not sure, you can always draw in the midline and sketch from your starting x that reciprocal function. Mr. Kukla, it's not secant, it's cosecant. See, it's really useful to draw in that reciprocal function. So cosecant has one up, one down, and secant is the one that looks like a part, a half, and a part. Or a negative secant would be a part, a half, and a part. Okay, so that's problem number 31. Let's take a look at 32. Oh, 32 is our secant graph. 32 has vertical asymptotes at 9 9/9 and 13/9, and this goes to 7/9 1, and this goes to 11/9 -1, and then this piece goes to 15/9 1. Okay, again, let's think about our period. Period is ending x minus starting x. 15/9 minus 7/9 equals 8/9. And therefore our b value, 2 pi over the period, will be 2 pi over 8/9, or 18 pi over 8, which reduces to 9 pi over 4. We need to find our c value. Again, our c value is this starting x. We need to find our d. D is the average of the high y value and the low y value. So we've got 1 plus negative 1 over 2, which is 0. And our a value is that high y minus d, so 1 minus 0, or 1. Remember, we could also do, instead of high y minus d, we could do d minus low y value and still get 1. So my equation, y equals, the amplitude was 1, secant, our b value was 9 pi over 4, x minus 7/9, close to parentheses, plus 0. I probably wouldn't write the 1 or the plus 0 and would write y equals secant 9 pi over 4 x minus 7/9, close to parentheses. You're welcome to distribute there, but I find it's not, I wouldn't. Just so many people make little distributing mistakes, and then the 5-point problem is wrong, and then we're all sad. So don't do that. 33. 33, well, you know, what do you see here in 33? Do you see a sine graph starting here and ending here? Or do you see a cosine graph starting up here and ending up here? We can write either equation. Our a, b, and d values will be the same for all of these, for both of these functions. The only thing that would be different is our c value, and we can talk about that in a minute. Okay, I'm going to start because most students see this as a positive sine graph, sine x. So, and they see, now it's important when you look at this graph to say, this is one period. The period starts here and period ends here. Don't use this x value and this x value to find your period, because that's more than one period. Our period starts here, we go through one cycle of sine and stop, and that's where that period ends. Okay, so we're going to end at 7 pi over 12 negative 1. We're going to start at negative pi over 12 comma negative 1. And our low point, 5 pi over 12 negative 2. And our high point, pi over 12, 0. All right, so let's see. Our period, 7 pi over 12 minus, that's a negative pi over 12. That gives me 8 pi over 12, or 2 pi over 3 if I reduce. My b value will be 2 pi over the period, so 2 pi over 2 pi over 3. And when we simplify, we should end up with 3 there. Okay, we know our c value for positive sine is here. C is going to be negative pi over 12. If we were doing this as a positive cosine graph, our positive cosine graph would start here. And so this would be our c value. C would equal pi over 12. Okay, we've got b, we've got c. How about d? D is the average of the high and low y values. So 0 plus negative 2 divided by 2 is negative 1. And we can see that midline labeled on our graph already. Our a value is the high y minus that midline, and I get 1 for a. So I could write y equals 1 sine, our b value is 3, x minus a minus pi over 12, plus a d value of negative 1. Don't forget to close that second parenthesis. I'd probably tidy this up to be y equals sine 3x plus pi over 12 minus 1. But like I said, we could also have written this as a positive cosine starting up here, in which case we'd have cosine 3x. This is pi over 12, so we want minus pi over 12, because we're shifting to the right, pi over 12, minus 1. The only thing that's changing from sine to cosine here is, are we starting here with a positive sign, and therefore our c is negative pi over 2, or are we starting up here with cosine for positive cosine, in which case our c is positive pi over 12. Sorry, that was negative pi over 12 and positive pi over 12. Okay, 34. Let's take a look at 34. 34 says, what do you see? Do you see cotangent or do you see negative tangent? We've got 5 pi over 12 negative 2. This is pi over 6, and this is 4 pi over 6. The period is the distance between these, so period equals 4 pi over 6 minus pi over 6, which is 3 pi over 6, or pi over 2. And if I'm looking for my b value here, remember, it's not 2 pi over the period, it's pi over the period, because we're talking about tangent and cotangent, and the normal period for tangent or cotangent is pi. So we've got pi over 2, so I get a b value of 2. Now my d value is really easy. It's right here. That's my d value. And remember, since we're not worried about quarter points in going forwards graphing, we're not going to worry about an amplitude going backwards either. So I see this as a I see this as a cotangent graph, in which case this starting x is my c value. So I would write y equals cotangent b value x minus c value pi over 6, and then our d value minus 2. But if you saw this as a negative tangent graph, you would write y equals negative tangent 2 x. Now wait a second. We don't look here for our c value. We look at the 0 point on the graph. And on the tangent graph, this is the 0 point. So this is my c value for negative tangent, minus 5 pi over 12 minus 2. We talked about that last Thursday. Here we go. Our b values are the same and our d values are the same. We're not worried about a values going backwards with tangent or cotangent, and so all we need are these two different c's. Starting x is the 0 for cotangent, and inflection point x is the 0 for tangent. So this was problem number 34. Let's take a look at 35. Well, I start high and I go here. Oh, but look, the graph kind of continues down. And this looks like the point 0, 3. And I've got a high point here at pi over 2, 5. I've got pi 3. I have 3 pi over 2, 1, and 2 pi, comma, 3. Okay, so what do you see? Do you see a sine? Do you see a cosine? Well, let's do both, because some people don't see this point, and they really do see the graph starting here. So first, though, the sine. I know the period is the x difference in x values in one cycle of sine. So here's my ending x, here's my starting x. Period equals 2 pi minus 0, or 2 pi. Okay, and then I know that my b value is 2 pi over the period, so 2 pi over 2 pi equals 1. Now, let's imagine that I didn't see this point here, and I needed to figure out the period. Well, from here to here isn't a full period. I would need back up to the high point again. And I don't know where that point is. Well, I can figure it out using quarter points. How far is it from here to here? Pi over 2. How far is it from here to here? From pi to 3 pi over 2, it's another pi over 2. How far is it from here to here? From 3 pi over 2 to 2 pi, that's another pi over 2. So if I add pi over 2 to this, I'll be able to get to this point. This will be 5 pi over 2, comma, 5. And then I could use the period as 5 pi over 2 minus 1 pi over 2. and I get 4 pi over 2 or 2 pi again. Same period, I'm just counting from a different place. Okay, so we have our b value, and I saw this as sine starting here at 0, 3, so that's my c value. Of course, if you saw this as a positive cosine, this would be your c value. Okay, what else do we need? We need d. D is the average between the high and the low y values. And a is going to be that high y minus d for 2. I guess we could also say d minus the low y for 2. So we've got our values for a, b, c, and d, and we can write y equals 2 sine 1 x minus 0 plus 3, which I guess we could tidy up to be 2 sine x plus 3. That's much tidier. Or we could write a positive cosine and have this be our c value. Y equals 2 cosine 1 x minus pi over 2 plus 3. Okay, so that's number 35. Let's take a look at 36. 36 makes me want to say, do you see a tangent or a negative cotangent here? We've got vertical asymptotes at negative pi over 18 and positive 5 pi over 18. So the distance between those is the period. This shape always makes me think about positive tangent. And we have this inflection point here at 2 pi over 18, comma, 1/3. All right, so period 5 pi over 18 minus a minus pi over 18. That's 6 pi over 18 or pi over 3. And we know that this is tangent or cotangent, so our b value is pi over the period. So pi over 3 gives me 3. This is our d value, how much we've shifted up. We don't worry about an a value going backwards with tangent or cotangent. So what else do we need to find? Oh, a c value. Well, again, the c value depends on whether or not we see a positive tangent or a negative cotangent. This is where we look for c for tangent. And this is where we look for c for cotangent, negative cotangent. So I can write the following equations. Y equals tangent, our b value was 3, x minus 2 pi over 18, or pi over 9, and our d value was 1/3. Or we could write a negative cotangent, y equals negative cotangent, 3x, but this time this is our c value, minus a minus pi over 18 plus 1/3. And I'd probably tidy that up to be plus. Okie doke. There's 36. Let's take a look at 37. We're almost done going backwards, and then we'll have a few inverse trig functions to graph. 37, well, I see a negative cosine graph because I'm starting low at 0, 1/2, going to a high point at pi 3/2, and back down low to pi 1/2. The distance here for our period is 2 pi, because 2 pi minus 0 is 2 pi. Our b value, 2 pi over the period, is 2 pi over 2 pi, or 1. Our d value, 3/2 plus 1/2 divided by 2, that's 4/2 divided by 2, or 2 divided by 2 for 1. Our a value is 3/2 minus 1, which is 1/2. And our c value is our starting x. So c equals 0. So I would have y equals 1/2. Oh, careful. This starts low. This needs to be negative 1/2 cosine 1x minus 0 plus 1. And you could certainly tidy that up to be y equals negative 1/2 cosine x plus 1. Okay, there's 37. Let's take a look at 38. You know, I know that this graph comes down and passes through 0, 0. So I should probably think about doing this as a sine graph, a positive sine graph. But I saw these two well-labeled points up here, 1/2, 3, and over here, 5/2, 3. And I thought, oh, well, this is positive cosine, and my period is 5/2 minus 1/2, or 4/2, or 2. But you know, you could certainly see that here, because this point on the graph is labeled as 2, and this one is 1. And so here's one cycle of sine going from 0 to 2. But I saw it starting here and ending here. Okay, so our b value, 2 pi, because we've got a positive cosine graph, over our period of 2 pi over 2, and so our b value is pi. Our d value, the average of the high and low y values, this one is 3/2, negative 3. So if I average 3 plus negative 3, I end up with 0. My a value is the high y minus d, or 3. And my c is my starting x. Now, if I had seen this as sine, my c value would be 0. But I saw it as cosine, so my c value is 1/2. Y equals 3 positive cosine pi x minus 1/2 plus 0. And I probably wouldn't bother with the plus 0 when I wrote this down. Of course, if you saw this as a sine graph, you would have written y equals 3 sine pi x minus 0 plus 0. In which case, really, sine pi x. Okay, and that was the last of the going backwards problems. Now we've got 6 inverse trig problems. Let's take a look at these. 39. We've got arc tan of 2x plus 1 plus pi over 3. We know that arc tan is a synonym for tangent inverse of 2x plus pi over 3. When I think about the inverse tan reference graph that we talked about on Friday, it's got one reference point, but it's got these two horizontal asymptotes, one at negative pi over 2 and one at positive pi over 2. So any x transformations, that's the only x value, so they all apply to that. And any y transformations apply not only to this y value, but to these y values as well. And so I usually write this as 0, 0, y equals negative pi over 2, y equals pi over 2. And then I apply my transformations. I see I'm supposed to subtract 1 from the x's, and I'm supposed to add pi over 3 to the y's. Pi over 3 plus pi over 3 plus pi over 3. And so where are we now? Well, now I've got negative 1 pi over 3, y equals, I need to make a common denominator here, negative pi over 2 plus pi over 3 is going to be negative 3 pi over 6 plus 2 pi over 6, which is negative pi over 6. So this is negative pi over 6. Here I'm going to have 3 pi over 6 plus 2 pi over 6 to get y equals 5 pi over 6. Okay, we're almost but not quite done. Remember, we still have to divide the x's by 2, and that's my only x. So what does my graph look like? We have a horizontal asymptote at y equals 5 pi over 6, another horizontal asymptote at y equals negative pi over 6, and we have our same characteristic shape with an inflection point located at negative 1/2 pi over 3. Okay, that's 39. 40 is another inverse tan problem, or arctan, and we've got, for number 40, y equals 2 tangent inverse x over 2 plus 3 minus pi. And again, I'll start off with 0, 0, y equals negative pi over 2, and y equals pi over 2. I'm going to subtract 3 from all the x's. I'm going to multiply the y's by 2. So that gives me negative 3, 0, y equals negative pi, y equals positive pi. And then I'm going to go back and I see this dividing by 2. Inside is opposite land. That means I need to multiply by 2 there. And when I look at this other y transformation, I'm supposed to subtract pi from all the y's. So my final points then are negative 6, negative pi, y equals negative 2 pi, and y equals 0. So I have horizontal asymptote at y equals 0. I have another horizontal asymptote at y equals negative 2 pi. We have our characteristic shape and our inflection point at negative 6, negative pi. Negative pi, not positive pi. Make sure you've got a negative there. Okay, there's problem 40. That was inverse tangent, or arctan. Now we've got arc cosine, or inverse cosine. Remember, our reference graph for this looks like this: negative 1 pi, 0 pi over 2, and 1, 0. So I'm going to start off with those reference points when I look at y equals arc cosine x minus 2 plus pi over 2. I see one x transformation, I see one y transformation, and I'm going to apply those to these reference points. 0, pi over 2, 1, 0. I'm going to add 2 to all the x's. I'm going to add pi over 2 to all the y's. And so I end up with 1, 3 pi over 2, 2 pi, and 3 pi over 2. Notice the furthest left point has the highest y value, the lowest right point, the furthest right point has the lowest y value. So I still have my characteristic shape, 3 pi over 2, 2 pi, and 1, 3 pi over 2. Okay, there's our inverse cosine for number 41. Let's take a look at 42. It's also an inverse cosine, but it has more transformations. Problem number 42, y equals negative arc cosine 2x plus 1 plus pi. So I start off with my reference points, negative 1 pi, 0 pi over 2, 1, 0. And I start by subtracting 1 from the x's and multiplying the y's by negative 1. That gives me negative 2, negative pi, negative 1, negative pi over 2, and 0, 0. Okay, what's next? Well, now I have to divide the x's by 2, and I have to add pi to the y's. And so I get negative 1, 0, negative 1/2 pi over 2, and 0 pi. Notice this time, the furthest point to the right has the lowest y value. I'm sorry, furthest point to the left has the lowest y value, whereas the furthest point to the right has the highest y value. Why is that? Well, I've got a reflection. I'm taking this graph and flipping it upside down. So our characteristic shape looks more like an inverse sine than it does an inverse cosine. It's a reflected inverse cosine. So this is negative 1, 0. This is negative 1/2 pi over 2. And over here we have 0 pi. There we go. That's number 42. Only two problems left. They're inverse sine or arc sine. Let's take a look at that reference graph. Y equals sine inverse x. It has this characteristic shape, passing through 0, 0, passing through negative 1, negative pi over 2, and passing through 1 pi over 2. Okay, and if you forget these points, you can always say the sine of pi over 2 is, the sine of negative pi over 2 is, the sine of 0 is, and these are our angle restrictions for sine. Remember, we go from negative pi over 2 to pi over 2 for inverse sine. Okay, so what are we looking at for number 43? I've got y equals 1/2 arc sine 2x. So I've got an x transformation, I divide the x's by 2. I have a y transformation, I multiply the y's by 1/2. So negative 1, negative pi over 2, 0, 0, and 1 pi over 2. I'll start by multiplying the y's by 1/2, and then I'll divide the x's by 2. So I end up with negative 1/2. Be careful here. Negative pi over 2 times 1/2 is not negative pi, it's negative pi over 4. A lot of students do this in their head, and because they're rushing, they miss this, and they call it negative pi. Watch out for that, please. Negative pi over 4, 0, 0, 1/2 pi over 4. And so we have our characteristic shape. We've got negative 1/2, negative pi over 4. We've got 0, 0 because there was no shifts either up or down or left or right, no C or D values here. And then finally we have 1/2 pi over 4 is our high point. And that's our graph for number 43. The last problem, number 44, will use the same reference points and the same characteristic shape, except it has more transformations. In number 44, I see y equals 2 arc sine x over 2 plus 1 plus pi over 2. I'll start with those reference points again. They were negative 1, negative pi over 2, 0, 0, 1, pi over 2. And what do we need to do? Well, we need to subtract 1 from all the x's. And out here, I see a 2. I need to multiply all the y's by 2. So my new points are going to be negative 2, negative pi, negative 1, 0, 0, pi. I still have two more transformations to do. Here I see this divided by 2, which means I need to multiply all the x's by 2. And here I see a plus pi over 2, so I need to add pi over 2 to all the y values. And so we end up with negative 4, negative pi over 2, negative 2, pi over 2, and 0, 3 pi over 2. We have that same characteristic shape. This point is negative 4, negative pi over 2. This point is negative 2, positive pi over 2. And this point up here is 0, 3 pi over 2. And that's our last problem, number 44. I hope this helps. Sorry it wasn't there when you needed it yesterday. Have a nice night, everyone.